And from here, we take you to the live press briefing by ISRO Chief, Dr. S. Somnath.
50 kilometer circular with a 6-degree inclination. The orbital injection accuracy is so good, so we don't have to do any further amends to it. And after that injection, the PSLV 4th stage will be lowered to a 350 kilometer circular orbit to carry out the 9 payload experiments which are there on board. So we are waiting for it to happen. Many of the events are not in the visibility zone, so when the data comes, we will update you. So as far as this PSLV goes, it has very uniqueness. One is, of course, is the 60th launch. Then this satellite is a very unique satellite, complementing the scientific objectives that we have set for various observations of the universe. It goes with AstroSat. It goes with the Aditya L1. So it's a class of satellite which is observing the universe in various frequencies, spectral bands, as well as in this satellite there is something very unique, the polarization measurements of the X-rays, which are coming from distant objects. Of course, all its details are there, and we will discuss it if you have any specific questions on it. And also it indicates the collaboration that is possible between ISRO and other scientific institutions of this country. The primary payload is made by the Raman Research Institute, and the second payload is made by the astronomy group of UR Rao Satellite Center, like what we did for the Aditya L1, where the primary payload was from Indian Institute of Astrophysics, and other collaborating agencies like the Inter-University Center for Astronomy and Astrophysics. So it also shows how ISRO is collaborating with other scientific institutions, developing capacity of using the data across academy and other places in specifically science missions. Of course, PSLV has again done its job very well. And this poem this time is very unique because we want to lower it to a lower orbit, like 350 kilometer, because it had enough propellant to do that. And we want to make so that the experiment is very, very less. And we can carry out the onboard experiments with the onboard power generation, with solar panels, its own computers, control system, etc. So we will seek more questions on any topic because it is a new year. Of course, you will ask me about what is waiting for in 2024. I am very aware of it. So we have my center directors and others assembled here who have the responsibility to make the rockets and spacecraft. So over to you for any further questions. See, always happy to see girls students excelling in science, engineering, etc. You already heard that ISRO is having a very fair share of the ladies scientists who are working for all our missions. So like that, when such a satellite comes from an institute, which is a women's institute, and they have built the satellite with collaborating with ISRO, and we were very happy to host it on board PSLV poem. It's an inspiration, not for ISRO, it is for entire country, no? When girl children are spending their time to study science and they are excelling in their domain, we must all appreciate. So congratulations to the VSAT team, especially the LBS Institute. Thank you.
Sir, I meant you ended your brief, go on the year ahead, just elaborate what can we expect?
In 2024 is going to be a year for Gaganyaan readiness. Of course, Gaganyaan manned mission we have targeted for 2025. If you are able to do everything in 2024 very well, that target will become difficult. So we have to focus on what you want to achieve in Gaganyaan for 2024. So to have details, the beginning of the Gaganyaan program started with the TVD1 mission of the abort mission. We have 4 in the series. At least 2 more we must do in 2024. So that is our target. So by that we will have the 3 abort missions demonstration. Then we must do at least 1 unmanned mission. Our target is to do 2 unmanned missions, beginning of this year as well as end of this year. That is our target. Let us see, with respect to the preparedness of various hardwares, etc., we will target that. So that becomes one package, 2 unmanned missions and 2 test flights. It's a huge effort. Then, of course, along with that, we will have a helicopter-based drop test to prove the parachute systems. There will be multiple drop tests. We also will have a pad abort test, which is called the launch pad abort test, and many hundreds of such validation tests, including environmental control alloy support system related test, the crew module related test, simulation test beds, and hundreds of them, which I cannot even describe. So it's going to be the Gaganyaan year. Along with that, we are going to have launches of GSLV for NISR. This year itself, we are going to have first flight of GSLV with the INSAT 3DS, which is now going to happen soon. Vehicle is almost ready. And the second flight of GSLV will carry the NASA ISRO synthetic aperture radar satellite. So that means 2 of the GSLV flights are minimum required. There are some more in pipeline, including the NAVIC second series of NVS-02 also should be launched this year. We have SSLV launch now scheduled. The second flight of the SSLV, third flight of SSLV, which is to happen now with the satellite, so that is also getting ready. Rocket parts are ready, satellite is just completing its final phase of integration, so it will take 1 or 2 months more. We have also PSLV missions, which are going to be commercial missions. At least 2 commercial missions for an NSIL is scheduled next year. We also have other remote sensing missions of PSLV. So there will be multiple PSLV missions. I am not giving you the numbers, because the numbers, if you start counting, they will be very large. So we would like to see the reusable launch vehicle landing experiment you saw last year. That landing experiment we have to now demonstrate it with other experiments more we are planning in 2024 with the different start conditions so as to validate its extremities handling capacity. So this is yet another flight. Then we have to do a scramjet test demonstration, which is we have done one test flight during few years back using hydrogen as a fuel. So with the kerosene as the fuel, we are going to test the scramjet now. So that vehicle is undergoing testing in the ground, and we are going to have the scramjet test in sounding rockets this year. So I think I have counted very large numbers already. So, yeah, only in 12 months we have to have minimum 12 missions. That is our target. Of course, it may exceed depending upon our ability to produce hardwares, complete the testing, and things that goes well. If it is not going well, of course, there could be impact. Otherwise, we are getting ready for at least 12 to 14 missions.
The research about black holes, supernova, and neutron stars. How is it going to, how will it help in promoting the knowledge for Indians and the entire world? And why are we only going for X-ray detection and no other radiation from these cosmic sources?
Okay, I could have answered, but then I will request Shankaran to answer.
Okay.
Switch on.
By very nature, black holes don't give any information out. That's why it is called black hole. It cannot give its own gravity to get out of it. So that is its own light also to get out of it. So there is no way to directly study the black holes. The only way to study black holes is when the black hole is tied to another object, which is an X-ray emitting object, and they together as a binary star. That is 2 stars together when they are there. The X-ray that is coming out of this X-ray emitting star is getting modified by the black hole. That how the X-ray gets modified by the black hole tells what is the characteristic of the black hole. That is how the black holes are going to be studied. Otherwise, there is no way of studying black holes. So this is a completely new science area. Around the world also a handful of people only are working in this domain area, and it is to the credit of our scientists in India that such a payload has been configured, realized, and now it is up in the orbit. We are all hoping for good science out of this.
Sir, good morning. Karthik here from TT. You said life of after the 4th stage is less. Can you define that? How is it? 6 months this payload will be ready? Number one, and another is can you give us an update on RTL?
Okay, the life of an object in orbit is determined by its orbital height. When the orbital height is lower, it will encounter more drag. You know, atmosphere is there even up to that altitude, very thin atmosphere. So you will end up with a drag, very low drag, and slowly the altitude will decay. So if anything is below 350, its life will be less than few months. So the decrease in altitude will be much faster than being at 450 or above. So typically all Earth observation satellites are placed in high altitudes 500 and above so as not to cause any degradation significantly. The life will further depend upon various other parameters like mass, its area, etc. because the drag is a function of various things. So it is not a unique number for any object. Depending upon the plan area, the drag area which is going to vary, you can, and similarly the propellant available to keep it in orbit, etc. But for this stage, we are not going to keep it in orbit. There is no way to maintain the orbit. We are only maintaining the orientation while experiments are taking place, so as to maximize the energy generation from solar panels. It has a body-mounted solar panel. So our experiments are going to last only less than a month. Within a month's time, all experiments objectives will be met. So after